Hello users, how are you? Today we are going to discuss about software internal design principles, and there are some design principles. If we follow those principles, we will definitely have a better design. The first principle is modularity. We should divide the software into modules, and the modules should be as small as possible. Because when we divide the software into modules, it gives us different you can say features. It provides us flexibility, and it provides us easy to fix mechanism of errors. Like if your software is composed of smaller modules and one of the module goes out of order, you can replace only that module instead of replacing the whole product. So modularity is very important and very good, very important design principle. The next is interfaces, and interfaces is here. The interfaces doesn't mean the graphical user interface. Rather, here the interfaces means the internal interfaces of modules. The modules, these interfaces should be generic, so and easy to use. If all the modules have almost same interface, generic and consistent, then we can easily connect and disconnect different modules. The next goes information hiding, and information hiding is very important uh, for two reasons. The first is security, uh, and the second is user get confused with non-relevant information, so we hide the information. And next is incremental development, and incremental development means that you should uh, develop the software module by module, and it's also very uh, good design principle, because this way you can get the feedback from the end user, and you can change your course of action if you feel that you are not on the right track. And also, if you develop the software module by module, and you can easily segregate the bugs and errors. uh, Abstraction means uh, you should hide the implementation details, and it's also very important for to achieve a generic interface and standardized interface. And when you hide the implementation details, uh, it you also you can say create an opportunity for the users to learn the to have the consistency in the product. Like uh, just see the example of brakes in vehicles. All the vehicles have same mechanism of applying brakes. You push the pedal and brake is applied, but the implementation detail of every brand of vehicle may be different. For example, in Toyota they may have different implementation, and Honda and RDI they may have different implementation. So by abstraction, you standardize the interface and hide the implementation details. So the other benefit of abstraction is that users focus remains on the problem instead of code, because user should uh, solve the problem, and you should have focus on the problem only. Next is generality. The code and design should be as generic as possible, and here is an example of generality. Like this is a function. Here you can see this is a very non-generic function. Here you have three global variables. First of all, you change the values of these global variables, and then you get the new sum. To make it more generic, what we did, we used three parameters as three variables as a parameter of a function. And these so this is more generic than this function, because we can uh, easily pass on new values to this function and we can get the sum. But again, here we have some limitation, because we cannot pass on more than three variables as arguments. So to make it more generic, we use an array, and also provide the length of the array. So this way we can pass on more than three values, then we can get the sum of these three values. But here we have another limitation because we have to know the length of the array in advance so that we can pass it on. To solve this problem, in the next procedure, we use a flexible array, and this is the more generic way than all the previous ways. So the this is the key principle that the code and the design should be as generic as possible.